Good morning, everyone, and thank you to Fabio and to the organisers for the invitation to come to Icomst and for the opportunity to visit Uruguay for the first time. Okay. And for the very nice weather. Although it is winter here, the weather is actually warmer and sunnier than it is in Ireland at the moment, where it is summer. So it's very nice for me. So this morning I will give a little bit of a perspective on European beef safety, which differs quite a bit from the North American approach, and Dr. Wheeler has just very nicely overviewed many of the interventions which are used in the US beef industry, both pre-harvest and post-harvest, but almost none of these are actually permitted for use within the European system. So a very different approach. So this morning I will be talking a little bit about how we assess and monitor for both microbial pathogens and chemical contaminants in the beef sector, and the approach to managing these both at a regulatory level and at the industry level. My own area of expertise is in the microbiology area, and my colleague Martin Danaher, who works with me at the Chagas Centre in Dublin, has given me some information and some slides on chemical contaminants, which are also important from a European beef perspective. So some of the topics that I will cover this morning is I want to give just a little bit of an overview of the European beef industry, the diversity that exists within it, and some of the challenges posed, particularly those which are relevant to assessing and managing safety. I'll then talk a lot, as it's my own key interest, on microbial pathogens, particularly things like the E. coli's, the salmonellas, how we assess and manage risk related to these, and then the same in relation to chemical contaminants. And then I'll talk a little bit about emergent issues. It's quite a dynamic time in Europe at the moment in the whole area of regulation and policy in relation to beef safety, and there are some new regulations relevant coming on board at the moment, or will come on stream before the end of the year, which will, I think, impact quite significantly on the day-to-day business within beef operations. So I'll talk about those. A little bit about some new hazards that we're seeing in terms of microorganisms and chemicals that maybe need to be on the radar for the future, and very briefly about some advances in the scientific and technical areas which will, I think, help us in the future in terms of assessing and monitoring pathogens and contaminants. So a little bit about the European beef industry. We have figures called from a statistical source called Eurostat, which in 2012 estimated that the EU cattle population was 86.2 million head, so quite extensive. But this is across very diverse production systems across the EU 27 member states. So it ranges from very small family holdings with just very small numbers of animals to very large and intensive production systems. We have animals which are fed on grass and pasture, as well as animals which are fed on concentrated feed. So you have the two ends of the spectrum. We have animals which are raised through specialised beef production systems coming from beef suckler herds, as well as animals produced through the dairy system, and then the animals from those obviously ultimately feed into the beef chain. And actually about 2/3 of the animals coming into the beef chain in Europe would come in off dairy production systems. There are also smaller systems related to, for example, to production of veal. So it's very, very diverse across the EU 27 states. And in fact, 7 EU member states, which is France, Germany, Ireland, the UK, Spain, Italy and Portugal, account for 75% of all EU cattle production. There has been a trend over the last 10 years or more for a slow, really, decline in beef production, and current output would be estimated to be about 8.1 million tonnes. The latest figures would suggest that our imports in Europe have been decreasing slightly, but in fact, in recent years, exports have actually been increasing, mainly as a result of new markets opening up, particularly in Turkey and in Russia. And 2012 figures estimated that about 20 to 30% of all EU beef was actually going to Turkey and Russia. Obviously, with the current political situation in Russia, there is now a temporary ban on beef and stuff, so only time will tell how that scenario will develop. A very interesting change has also been a very recent lifting of a ban on EU beef by the US, which was in place for 16 years. And I certainly know the Irish beef processors are seeing this as a huge opportunity and have very active plans to be exporting beef to the US by the autumn of this year. Other market opportunities are in areas like Asia, the Middle East, and North Africa. So with this huge global trade, really, it highlights the need kind of for agreement and harmonization in relation also to safety aspects, which may impact on trade across the regions. Within Europe, beef accounts for about 21% of all meat consumed in the EU. This would be just a little bit lower than for chicken, but which I think is around 20%. But about 60% of meat would then be consumption would be pork. So over the recent years, both the purchase and the consumption of beef in Europe has been affected by the economic situation, with the economic crisis. Instability and austerity measures have impacted on consumer purchase of what would be seen, certainly in the fresh meat market, beef would be seen as to being more expensive, and it has been hit certainly in Spanish and Italian markets has been impacted. It also can be impacted by risk perception, and we heard this morning earlier about how consumers may view beef as not having health concerns, and that may affect their purchase. If there is safety outbreaks or crises related to beef, it impacts on purchase by the consumers. And we've seen then from 2013 that fraud can also significantly impact. And I'm sure you're probably all aware of the large horse meat fraud in 2013, which spread right across the EU, where horse meat had been substituted into processed beef meats, both beef burgers and meals like lasagna, etc., many meals which are prepared from beef, which were shown to not actually contain beef as labelled, but were actually containing horse meat. It started with a very small survey of products by the Irish Food Safety Authority, and really escalated from that, which showed really that it spread right across Europe in terms of really a criminal fraud with, say, horse meat being substituted for beef. It very badly impacted on the processed beef markets, not so much on the fresh beef. And the EU put in a very large action plan as a result of this, which included DNA testing for meat speciation, horse passports so that there would be better traceability, and ensuring where horse meat was legitimately going into the food market that there would be records, and that residues like phenylbutazone, which really was the only potential safety aspect related to the fraud, where there were concerns that there may have been residues of this drug in the beef, so that would be better controlled. A new EU fraud network has been established with better cooperation between Europol and the food safety agencies and the police, as well as a rapid alert system for fraud, similar to what already exists for safety. So this is really how this situation has been addressed. and I gather there is another round of meat speciation testing across the member states planned for later this year. So really it very much highlights that to protect markets both within the EU and for export markets, and to maintain consumer confidence, that beef needs to be underpinned by the highest standards of beef safety. So beef safety requires very much a total chain approach. A contaminant which enters the chain at the feed stage can end up in a problem in the meat for the consumer, and we've seen that evidenced in cases where there was salmonella in animal feed, which was the same one then isolated in human illness, and also in the dioxin issue where animal feed contaminated with dioxin was detected in the meat for consumption. The key issues really are, for safety, really are microbial pathogens and chemical contaminants, and they will be the focus of what I'm going to talk about today. So just a little bit in the EU, who are the risk assessors? Well, really the risk assessors should be the scientists who are generating solid data on what is the risk. So it's the scientists who are then feeding into the national food safety agencies, and who all feed into the European Food Safety Authority, who has the remit for doing risk assessments of their own accord, but are also requested often to do risk assessments and generate scientific opinion for the risk managers, in particular the EU Commission. So the risk managers then are really the producers, the processors, the retailers. I should also include there the fast food producers who use obviously a lot of beef burgers, etc. They would also be a very big player. You have the national competent authorities who are the regulators at the national level, and then within the EU it's the EU Commission and DG Sanko who really have the role of the regulation at a European level, and say they cooperate very closely with the European Food Safety Authority. So that's really the way the system works, and if it's working well, there should be very close collaboration between the assessors and the managers. So in terms of microbial pathogens, as we've already heard this morning, and it's very well recognised, that bovine animals can carry a whole range of pathogens in their gut. They can be shed in the feces and then contaminate either fresh produce, the water chain, or they can get into the food or the beef chain during the slaughter process. Virus-cytotoxigenic E. coli and Salmonella would be two key pathogens on the fresh beef side, and Listeria monocytogenes is an issue in the processed beef sector. As we already heard this morning, the bovine hide in terms of slaughter and dressing would be the key source of contamination, but subsequent all practices and events during the processing, distribution, right down to cooking can also impact on the presence and the concentration of a pathogen in beef and the likely risk for the consumer. So within the EU, data on key human pathogens like the salmonellas and the VTEX, etc., are collated annually by different EU member states, and this data is fed into the European Food Safety Authority. Then on the human side, data on human illness, and particularly illness related to foodborne infection, is collated by the European Centre for Disease Prevention and Control, called ECDC. And this data from both sources, so what's in the food chain and what's causing human illness, are collated together annually into this community summary report called Trends and Sources of Zoonosis and Zoonotic Agents in the EU. So it's a very nice, really kind of a risk assessment approach as to what's in the chain and what's causing human illness. A lot of additional data is obviously generated through research and surveillance. So in the next number of slides, I'll try and really be having a little bit of a focus on what is the data that's reported through the community summary report, as well as some additional data through research and surveillance. For beef, really, the virus cytotoxigenic E. coli really topped the list in terms of importance, with cattle and other ruminants being well recognized as the major source of human VTEC. As we're well aware, the symptoms are substantially, or can be substantially more severe than other pathogens, ranging from mild diarrhea to very severe symptoms like hemorrhagic colitis or bloody diarrhea, or hemolytic uremic syndrome, which really is kidney failure, and a high fatality rate up around 10%. And it's often very young children or elderly who experience the most severe symptoms, and we've seen many outbreaks where with people infected. The virulence of this particular organism is related to its ability to produce virotoxin encoded by a gene called VTX, the virotoxin encoding gene, but also a number of other virulence-related genes which enable the organism to attach to the human gut. So it's been very much an evolving picture since E. coli 0157 first appeared in 1990 in North America, associated with a very big hamburger outbreak, and the picture really has continued to evolve right up to now. So in terms of the E. coli 0157, it was well recognized that the key virulence genes were the toxin, the VTX gene, and also this gene called EAE, which is causes an attaching and effacing lesion in the human gut. So very important in terms of human infection. In the 2000s, we've seen a number of other serogroups emerging, the top ones being 026, 0111, 0103, and 0145. But they did have a similar virulence gene pattern to the 0157. So in terms of testing for them, it made things a little bit more clear-cut. Everything changed then really in 2011 with the E. coli 0104 outbreak. It was an E. coli with the virotoxin genes, but it had a completely different set of genes related to attaching to the human gut, AAIC and AGGR. So it really did kind of really muddy the waters in terms of how do we actually assess the virulence posed by an E. coli carrying a toxin gene. And the situation now is that we see many diverse VTEC serogroups in human illness, and outside the VTX gene, they can have quite a variety of other virulence genes. So really a key question in Europe at the moment that's been grappled with is if you recover an E. coli from beef or indeed other food which is carrying the VTX gene, and with or without other virulence genes, what is the human risk and how do you actually manage that in terms of what do you do with it, what action do you take? Well, the starting point for this really was the risk assessors, or the European Food Safety Authority, sat down with a working group over a number of months, and last year published a scientific opinion on the pathogenicity of VTEC. And what it concluded was that it isn't actually currently possible to fully define human pathogenic VTEC or to identify virulence factors that absolutely predict its potential to cause human disease. So a little bit of a difficulty there in terms of how do you deal with this. But they did come up with a concept called seropathotype, which was really combining what is the serogroup of the VTEC and what are the virulence genes that it had, and that this could be used in some way to rank the risk potential of VTEC. So selected serogroups, which are not all serogroups would cause illness, but really in the top 90% or so, which are 0157, 026, 0103, 0145, 0111, and 0145, which had the VTX genes in combination with EAE or AAIC or AGR. That strains showing that combination of virulence factors are associated with a higher risk of severe illness. So they may result in hemorrhagic colitis or hemolytic uremic syndrome. Where you have a serogroup outside that top group of 5 or 6, but that also have the EAE, etc., virulence-related genes, the potential risk could be considered high for diarrhea, but unknown for the more severe symptoms like hemolytic uremic syndrome. In the absence of these virulence genes, so for example, an E. coli that's just carrying the VTX but doesn't have the EAE or the AAIC, etc., the conclusion was that no inference can be made regarding the human risk. So really quite challenging in terms of how do you actually adopt that then into the food industry as to what you do with a strain if you find it positive. And that's really ongoing at the moment at EU Commission level, with draft guidelines now in draft preparation and in discussion for what action should be taken on detection of a VTEC in food or meat. And what is being proposed at the moment is that there will be a ranking process for food. So foods will be ranked as either high risk or low risk. High risk foods being those which are ready to eat or would be consumed raw. So that would include, for the beef, that would include like traditional fermented sausages or steak tartare or filet Americain. And low-risk foods, which would be foods which would be cooked by the consumer before consumption. So that would be like your raw meat and your carcasses. And the proposed action would be for foods ranked as high risk, that there would be withdrawal of any food or meat with a VTEC isolated regardless of what serotype it is or regardless of its virulence gene profile. So in other words, any E. coli carrying a VTX gene, if it's present in a high-risk food, the action would be that it would be withdrawn. For low-risk foods, which would be our meat carcasses or our raw meats, withdrawal of the meat if a VTEC isolate of the top selected top 5 serogroups 0157, 026, 0103, 0111, 045 or 0104 with the traditional virulence genes EAE or AAIC and AGGR would be withdrawn. So a little bit of a difference there between the high risk and the low risk. But nonetheless, it will, I think, certainly there's a lot of discussion from an industry perspective at the moment about this and what impact it will have on their businesses. And it's something which is just really ongoing at the moment, and we'll see how it develops. It would be expected to be passed within the next number of months, albeit perhaps with maybe some changes. So just something about the overall trend for human VTEC infection in Europe. The blue line is the observed data with obviously the huge spike there in 2011 from an E. coli 0104 outbreak. But overall the trend, which is the long-term trend, which is the blue line, shows that overall there is an increasing incidence in human infection. 0157, these are figures now for just 2012 from EFSA, and in 2012, E. coli 157 accounted for 55% of cases, 026, 11.8, 091, 3.6. You might ask why this doesn't get included into the top list of serogroups, although it's quite commonly there, and the reason is it's generally not associated with very severe illness. It tends to be more diarrhea rather than hemolytic uremic syndrome or hemorrhagic colitis, and so on down the chain. But you can see quite a diverse range of serogroups causing human illness. This is just the shows really the difference in human infections across Europe, with the darker lines there appearing in the darker orange colour being the areas where there is a higher level of infection. So overall in the EU, it's the trend in 2012 was just over 1.15 cases per 100,000, but within that, Ireland is actually topping the leaderboard at the moment, with just short of 9 cases per 100,000, and that actually situation has not changed. Still, we're experiencing very high levels of VTEC infection. And in 2012, 6.2 cases per 100,000 in the Netherlands and 4.98 in Sweden. And the circles within there, you can see where in the purple part of the circle indicates the infections domestically required, and you can see in most of the countries where there is a very high instance that it is related domestic rather than travel or unknown. Just something about beef-related outbreaks. In 2012, there were 12 VTEC outbreaks in 6 member states where there was strong evidence of source. This isn't always the case, so it's only the ones where you have a track back to source of infection that are included in these figures, but 6 or 50% of those were linked to bovine meat or products thereof. And just one example of an outbreak in Belgium where 24 patients were infected. 4 developed HUS, 2 children and 2 women, and the source of outbreak was tracked back to a beef slaughterhouse and to consumption of raw meat products, including steak tartare. Other outbreaks over the last few years have been from 026 in 2007 in Denmark, related to beef sausage, where 20 people became ill. In the Netherlands in 2005, another steak tartare related outbreak, and a very large frozen beef burger outbreak in 2005 in France, where 69 became ill. So just very briefly, a little bit about the data that comes in from the EU member states on testing of meat and carcasses and of cattle. So just the collated figures for 2012, where cattle feces was tested across 7 member states. 7,843 samples were tested. Most of these were at an individual level, although some of them were at a herd level. In terms of all VTEC, 7.4% were positive, with quite a wide range between the different member states, going from 1.8 to 35%. And when you just look at 0157, 1.8% were positive, again with quite a high range across the member states, 0.3 to 8.4. Other serogroups recovered included 026, 0103, 091, as well as a range of other serogroups. In terms of testing for beef in 2012, 9 member states reported into EFSA on the testing of 4,600 samples, 1.3% positive for all VTEC, with a range between 0 to 5.7%, 0.1% on for 0157, with a range of 0 to 0.5. And other serogroups recovered were 026, 0103, 0145, and some others. So you can see that the levels actually on the carcasses actually are quite low, which is good. Just some additional data from EU research and surveillance studies, in particular from Ireland, where we have done a lot of work on VTEC over the years. Included in this are VTEC which have the virulence gene EAE, so they would be traditionally considered to be what's a high risk of virulence for humans. So the studies across the years really have ranged in animal feces, always taken at the abattoir, have ranged from 2.4% for 0157, 7.5% where samples were pooled in a 2011 study, and a more recent study where we looked at not just 0157 but some of the other top 4 serogroups, and the prevalence in the feces range 2.3% for 0157, 1.5 for 026, and 0.8 for 0145. And on dairy herds, interestingly, they were just a little bit lower, 0.6% for 0157, 0.2 for 026, and so on down, with none of the other serogroups recovered. On hide samples, 6.6% recovered in an early study back in 2005, and more recent study using the new methodology based on a PCR approach initially showed 17.4% of hides positive for 0157, but very little of the other serogroups. And as was seen in the EU member state studies, the prevalence on carcasses for 0157 and the other serogroups tends to be very low, although it was 3.6 in a study where samples were pooled, which would increase the sensitivity of the test. Just a little bit about the variation in the virulence profile. We would have recovered serogroups which then subsequently we found that were not actually carrying the VT gene, so they wouldn't be classified as VTEC. But I guess our question there from a research point of view is, are these serogroups actually losing the VT gene, and are they kind of an emerging issue there? Are they losing and gaining it? So are we getting a full picture? So overall, within the serogroups, most of the 0157s carried the VTX and the EAE, but a lot less in the serogroups that weren't 0157, with only 25% of all 026s and 0145s being classified into a virulence category, and less than 1% of 0103s. Some studies from Belgium on cattle feces, again showing similar results ranging from 1.5% for 026 down to 0.5 for 0111. A study done in Spain showing a high level on carcasses of 14.7%, and really no indication as to why this would be, except that it's probably just at the higher end of the spectrum and may be related to methodology or sites may be swabbed. Very interesting, in Poland, they tend not to find 0157, but in a recent study that was done, they found a lot of other VTEC serogroups, many of which carried both the VTX and the EAE genes. So the study really, and all that data really highlights that there's a huge difference in the epidemiological situation related to VTEC across European regions, and it is quite a challenge. In terms of risk posed, VTEC carriage and supershedders are a particular risk, and these are animals which are excreting very high numbers of E. coli 0157, more than 10 to the 4 CFUs per gram of feces. There's not a lot of data on whether the other serogroups like 026, etc., are supershedders, and that's very important information really that we need to know going forward. But certainly the impact of supershedders has been estimated that they contribute up to 80% of all VTEC transmitted on the farm, transport, lairage and slaughter. So they're a very important target in terms of risk management. And again, we have a lot of questions to answer in terms of what makes, why does an organism or an animal become a supershedder? Potential reasons put forward are that it may be a genetic variation in the VTEC strain, or something that's happened at the colonization site called the RAJ, which may be impacted by age or diet. And we have some ongoing, I think I have a little bit more time, yeah. Ongoing Irish studies looking at this topic, where we're looking at the frequency and the causes of supershedding in both dairy and beef cattle in Ireland, with a focus on 0157 and 026. Just some very recent work which has been done over the last 6 months, where we're swabbing the rectoanal junction at 500 animals over 3 abattoirs. Overall for 0157 we found 9.2% of animals positive and 5 supershedders, or 1%. And for 026 we have found 29% positive, 29 or 5.8 positive for 026, and with 3 supershedders. So it's certainly indicating that 026s are also showing this super shedding phenomenon, and that about 10% of all positive animals are supershedders. And over the next 18 months, this is an ongoing study, we will be looking at more animals, but also trying to collect some metadata on the animals, their age, what diet they've come in from, and the season, as well as collating more genomic information on the isolates from whole genomic sequencing, and using a metagenomics approach to look at what is the general flora at the rectoanal junction colonization site, and if fluctuations in this may impact on colonization with VTEC. So in terms of VTEC, the challenges really are that 0157 still remains the dominant, but really there is a huge emergence now of other serogroups. And as I said, the key questions and challenges is what is a human virulent VTEC and how we monitor it in the beef agri-food chain, trying to better understand carriage and shedding patterns and the behaviour of non-0157s, and understanding the causes of supershedding of VTEC 0157 and indeed in the other serogroups. A little bit about Salmonella. Overall within the EU there is a decreasing trend of human illness related to Salmonella. In 2012 there were 22 cases per 100,000 of population. Most of these attributed either to Salmonella enteritidis or Salmonella typhimurium. And the really interesting picture in EU is that we have seen emergence of this new variant of Salmonella typhimurium called monophasic Salmonella typhimurium. Basically, it's missing a particular gene on the flagella related to motility. But it has risen really over a very short period of time to be now the third most common cause of human illness, and it's also really emerged very rapidly within the animal population, both in certainly in pigs where there's data, and also in cattle populations. So in terms of where are Salmonella infections coming from, well, of 347 Salmonella infections, just 2% were related to bovine meat in 2012. And when you look at Salmonella typhimurium, 6.1% of cases were related to bovine beef. And of 7 outbreaks in total related to this new variant, monophasic typhimurium, 2 were linked to beef. And just an example of a very large outbreak in France in 2010 related to this new variant, monophasic Salmonella typhimurium. In this outbreak, 4 schools were involved, 1,500 were exposed, 544 cases, of which 31 were hospitalized. And the source was imported frozen beef burgers from another EU country. And the concentration of the Salmonella in the burger meat ranged between 270 and 18,000 CFUs per gram. And it invoked the rapid alert system really across the EU, and it really just highlights how quickly a new variant of a pathogen can suddenly become a major issue over a short period of time. Just something about the Salmonella testing in the EU in 2012. 8 member states tested 146,000 samples. 2.4% were positive, and on carcasses and processed beef, 9 member states tested 147,000 samples, and 0.2% were positive. Just a little bit of additional data from some research studies showing that on hides the prevalence would appear to be quite low, at less than 1%.
Finish.
Yeah, I'd wind up. I think I only got 40 minutes anyway. They gave me a shorter time when I started.
Okay.
So if I have another 5 minutes, that's okay.
Okay.
Promise 5 minutes. Yeah, it is only 12:10. So, as I say, the prevalence on hides is considerably lower than we would have seen for a VTEC, and also the prevalence on the carcasses is also quite low. Just showing that the trend for listeria illness in EU is about 0.4 cases per 100,000, with an increasing trend, and also outbreaks have been attributed to that. In terms of testing, 8 member states in 2012 tested 25,000 samples, 1.5% were positive for listeria. On carcasses, 8 member states tested samples and 0.2% were positive. I think I'll go on from that, but it's showing just the highlight on that really is that bovine hides are a very important source of listeria actually coming into the beef abattoir, with 27% positives in one particular study there. Within the EU, meat safety is really underpinned by a whole collection of legislation referred to as the hygiene package, which covers across the chain from specific rules for animal origin, hygiene of foodstuffs, and microbiological criteria. At the moment, under process hygiene criteria, salmonella is covered on pre-chilled carcasses, virotoxigenic E. coli isn't. And in terms of food safety criteria on ready-to-eat and processed meats, listeria and salmonella are specifically mentioned, but not VTEC. We heard a lot this morning about the bovine hide and the importance of that in terms of transmission. I suppose within the EU, some of the legislation does require that animals should be clean when processed in a slaughterhouse, and some EU countries do implement a visual scoring system for bovine hides, with animals classified in a dirtier condition subjected to logistic slaughter. And there is some debate about the correlation between visual cleanliness of hide and the presence of pathogens. But there is certainly none or limited uptake of industry of hide washing or antimicrobial treatments that would be used in the US. In terms of carcass washes, what is allowable is cold water washes, hot water washes, steam, and also from 2013, lactic acid is permitted, but to date it has not been adopted by the EU beef industry. For chemical contaminants, the legislation defines that the minimum number of bovine animals to be controlled or tested each year for all residues is 0.4% of the animals slaughtered in the previous year. And the aim is really each member state has a national residue monitoring plan, and the aim is to ensure compliance with the maximum residue limits and to detect illegal treatments. And the residues to be monitored come under both Group A substances and Group B substances. And you can see there what they are. For time, I won't go through them. But in 2012, 22 member states tested 130,000 plus bovine samples, and just 0.2% were non-compliant, which ranged across both Class A and B substances. New research on antihelminthics, which would be used in treatment of helminth or antiparasitic infections in cattle. New research looked at the risk posed and found low levels of ivermectin, and as a result of this, previously there was no MRL for ivermectin, but just in April of this year the EU has adopted a regulation for ivermectin in mammalian foods, including meat, of 30 micrograms per kilo in muscle and 100 in fat. Just a couple of slides, promise, just on meat inspection, which really is aimed at ensuring that the animals coming into the food chain are not going to transmit illness to humans. And current regulations date back many years, and they're based on an ante-mortem and post-mortem inspection, really looking for lesions related to things like TB, etc. So really they will not be purposeful in detecting things like microbial pathogens and residues. And to address this, the EU requested EFSA to deliver a scientific opinion on the health hazards which should be covered by inspection of meat, including identifying and ranking the main risks that should be covered by meat inspection, strengths and weaknesses of the current, and recommendations going forward. The risks were ranked based on the instance of human disease and evidence that meat or beef was an important risk factor for the disease. And very briefly, that ranking process has identified pathogenic E. coli and salmonella, as new ones which should be included there, as well as the cysticercosis and mycobacterium which were there previously. So the key elements going forward of the proposed system, which will be looked at now by DG Sanco, is that there would be a risk categorisation of animals presented for slaughter for high priority hazards, and that there will for the first time actually be testing of carcasses pre-chill for VTEC and as well as for salmonella at this stage of the chain, and that there would be removal of palpitation and incision of organs post-mortem, as this is contributing to spread of illness. Dioxins and dioxin-like phenols were ranked as the highest substances of risk for the chemical contaminants, and really the proposal is that monitoring programs should be more risk-based going forward. So those changes really based on that opinion are being looked at now by DG Sanco and will likely appear in regulation by the end of 2014. I won't say anything more about that other than emerging hazards related to pathogens are newer VTEC, new variants, antibiotic resistance, and in relation to chemical contaminants, risks from contact with plasticizers like phthalates, as well as illegal substances like thyrostats, which may be used to increase weight of cattle. Lots of advances in technical advances on the microbial side with next generation sequencing and mass spectroscopy on the chemical side. So that's my final slide, just really that the challenge for beef safety is for really, as I said in that first slide, for risk assessors and risk managers to really work in tandem to ensure the safety of beef for the consumer. Thank you very much. Okay. Apologies for